Great. So today our objective is to translate an inequality. So if you haven't already, these notes are on Schoology. And if I could put them in the right order. All right. So these notes are on Schoology. If you want to go ahead and print them and just follow along as we go, you can. Otherwise, you can take notes as we go. So verbal statements can be translated. I know how much we love translations. We're going to get plenty of practice so you feel more comfortable with these. Can be translated to algebraic inequalities, much like deciphering a secret message or translating from one language to another. All right, so like with our expressions, translations, I'm going to go ahead and give you some phrases that you'll see to determine whether or not we're talking about less than. You need to know this is less than, greater than, less than or equal to, greater than or equal to. All right, so here are some phrases for these. You might see smaller than. All right, so I went ahead and paused that so that I could type in these answers so that they were more legible. So if you need to pause this after I'm done going through them so that you can copy them, you can, but let me go ahead and go through them first. So some words that you might see to represent less than are smaller than, obviously less than, below, fewer than. Some things that you might see more than, or for greater than or more than, obviously greater than, larger than, above, exceeds. If we're talking about not only less than, but less than or equal to, you'll say maximum, because when you think about a maximum, you're like, this is the highest it can be, but it can be this. At most, again, you think about like the cafeteria. The fire marshal says that there is a maximum, or at most this many people can be in the cafeteria. You can have up to 50 people. You can have at most 50 people. So you can have 50 people, or you can have less than that. So at most means this is the highest it can be, but it can be this. No more than, again, this is the highest it can be. So it can be this or anything smaller than it. Less than or equal to. So the same kind of concept for greater than or equal to. This is the minimum. So you can score a 31, but you can't score any bigger than or any smaller than that. So we want it to be everything 31 or higher. At least this is the smallest it can be. Otherwise, we're going to need more. No less than, so it can be this, but higher, and greater than or equal to, because that's what it is. So a number is at most. At most. So a number is at most 15. So is at most is on our chart. Where do you see it? Less than or equal to. So what that says is this number can be 15, but 15 is the highest it can be, so it needs to be anything smaller than it. All right. The sum of a number and 3. So first off, sum means the answer in what? Addition. So the sum of two things, a number and 3, is less than. What it tells us is less than 12. A lot of this is just reading it, and I think if you use the chart when you read it and pick out those key terms, you should be golden. The quotient. Quotient is the answer in division of a number and -2. So quotient of number and -2 in that order. When it says quotient, the next two things that follow in that order, top to bottom. The quotient of a number in -2 is greater than or equal to. Well, it just told us is greater than or equal to 10. All right. I want you to do 4, 5, and 6. Pause it. Use your chart. And we're not solving them. Just use your chart to determine what it's saying. All right, are you done? You haven't paused it. Pause it. Work through them. All right. So by now, I have 4 less than. Less than means I'm taking 4 from something. A lot of you put in less than signs. 4 less than a number. So a number minus 4. This was one of our turnaround phrases when we were doing translations. 4 less than a number. So take 4 away from a number is at least. So where did you see is at least on that chart? That's right, greater than or equal to. So it can be that, but that's the smallest it can be. -6. All right, the difference. I see difference. So we know we're talking about subtraction between a number and 13 is at least. Again, is at least. Was on the chart under greater than or equal to is at least 1. All right, 8 less a number. So 8 losing, we don't know what, is less than or equal to. All right. So did you feel good about those? Awesome. So I'm just going to breeze through these just so you have plenty of examples, but I feel like you guys did awesome on those 3. 3 times a number. Times means multiplication. 3 times a number is more than, so is greater than -7. 1/2 of a number means we're multiplying a fraction or a percent times a number plus 5, because it tells us plus 5 is greater than 11. All right, -6 plus a number is less than or equal to 15. I just wrote what it said. All right. So now we're going to translate each statement, and then we're going to solve and graph it. Awesome. So the sum, so we're adding twice a number, so 2 times a number. The sum of twice a number and 4, so we're adding that to 4, is at least 16. Where do you see that on your chart? That's right, greater than or equal to 16. So then we can go ahead and solve it to get rid of our addition. Regular 2-step equation, order of operations backwards. So we're going to get rid of it. Addition and subtraction first. So -4. 2n is greater than or equal to 12. Divide 2. And our solution is n is greater than or equal to 6. So that's our solution. I saw a lot of people on homeworks and quizzes tell me the answer was 6. You have to include that inequality. That's part of the solution. And then, first question, is it an open or a closed circle? So 6, 5, 4, 7, 8. It is a closed circle because we're including 6. And all of the numbers bigger than it are to the right. Awesome. So 1/2 of a number of multiplying fractions or percents. 1/2 of a number. So 1/2 times number less 6. So minus 6 is greater than or equal to. I don't have to look at my chart. Is greater than or equal to 10. That's our inequality. Then we would solve it. Get rid of our addition and subtraction first. So subtraction with addition. So half n is greater than or equal to 10 plus 6 is 16. And then we are going to go ahead and get rid of times a half by multiplying. So we get rid of multiplication with division. Division of the fraction is the same as multiplying by its reciprocal, which is that fraction flip. If I flip 1 over 2, it's just 2 over 1. So both sides times 2. We know that this cancels. So we have n is greater than or equal to 16 times 2 is 32. So this is the solution. Now we can graph it. 32, 33, 31, 30, 34. All right, so first question when we graph it, is it an open or a closed circle at 32? It's closed because we're including 32. All right, and are we going to shade to the right or to the left? We want the numbers bigger than 32, so we're going to shade to the right. Awesome. All right. And then I'm going to do 12, and then I'm going to have you pause and do 13, 14, and 15. All right, so 3 times the number. So 3 times the number increased by 7. So plus 7 is less than 11. Less than 11. And if you want to go ahead and pull up your chart for our expression translations, that might help you for some of this. But those two charts will help you. But if you can already recognize them, you can go ahead and just have your writing inequalities chart with you. All right, so then we go ahead and solve it like a regular two-step equation. We get rid of our addition first with subtraction. 3n is less than 4. And then we're going to go ahead and divide both sides by 3. So n is less than 4/3 or 1 1/3. All right, so we can draw our graph. And we have 1 1 1/3, 1 2/3, 1 3/3. Below that, you'd have 2/3, 1/3. All right, so at 1 1/3, do I have an open or closed circle? Open, because we're not including it, and we want all the numbers smaller than that. That's right, we're going to shade to the left. Wanted to test it, I could. 1/3 is where I shaded. And is 1/3 smaller than 1 1/3? Yes, it is. All right. Now I want you to pause it and do 13, 14, and 15. Have you done that? All right. So I'm going to go ahead and I'm going to go through just the inequalities so you can check your inequalities. And if those are wrong, you can fix your work before solving them. So difference, 2 and a number. Difference is the answer in subtraction. So 2 and a number, subtraction, is at least -1. That's on our chart. So greater than or equal to -1. That was your inequality for 13. The quotient of a number and 5. Quotient is the answer in division. So number over 5, because remember division, put it in the order it gives you, is no greater than -9. That's on our chart. Well, on our chart, we have no more than, but same thing. So we're going to go ahead and say less than or equal to -9. All right, and then twice a number. So a number times 2, less than 20. It didn't say is less than, just less than. So subtraction is at most 10. So this is the biggest it can be, 10. And then is at most was also in our chart. All right. What did I do? It was in our chart. Is at most 10. So 10 is the biggest it can be. I looked at my chart wrong. Whoopsies. All right. So now that you've done that, if you didn't get any of these inequalities right, re-pause it and fix your math to get the solution. If you didn't, just wait a second because I'm going to start. All right. So by now, you were either waiting me to start because you got the inequalities right, so you want to see your solutions, or you've paused it and worked through them. Because now I'm going to go ahead and solve them. So I have 2 minus x is greater than or equal to -1. So I'm going to go ahead and get rid of my 2. So 2 minus 2 is 0. But I have a -x left is greater than -1 minus 2. So plus a negative. So -3. So negative x is -3. But I want to know what x is. So I'm going to go ahead and know that there's an assumed 1 there. So it's like multiplying by a -1. So we're going to go ahead and divide both sides by a -1. Let's start. I multiplied or divided both sides by a negative number. So we're going to say x, flip our inequality, is less than or equal to, because we want to keep that the same, -3. Sorry, +3, because 2 negatives is a positive. Oof. All right, so x is less than or equal to -3. So, sorry, +3. I keep wanting to say -3. 3, 2, 1, 4, 5. All right, so at 3, is it an open or a closed circle? Closed circle because we're including 3. And we want it to be smaller than 3. So you should have shaded to the left. Perfect. All right, so then we're going to go ahead and solve 14. So we're going to get rid of division with multiplication. So times 5 times 5 cancels, and you're left with n is less than or equal to -9 times 5 is -45. Does not matter that that 9 is negative. The number we multiplied both sides by was positive, so we leave it alone. So our solution is just that. N is less than or equal to -45. So -45, -46, -44, -43. All right. So when I graph it, open or close circle. Close because we're including 45. And then did you shade to the left or to the right? Right to the left. We want all the numbers smaller than that. Don't let the negatives throw you off. It's to the left is smaller than. All right. So then, regular two-step equation. 20, twice a number less than 20. Oops. Less than is a turnaround phrase, so Miss Hildebrand wrote that wrong. 20 minus 2n less than 10. If I threw you off because I didn't see the n. If it says less a number, go in that order, but it said less than, and it was a turnaround phrase. Start, because even experienced teachers sometimes miss that. All right, so 20 minus 2 times the number is less than or equal to 10. And so we're going to go ahead and subtract 20 from both sides. So -2n is less than or equal to -10. We're going to go ahead and divide both sides by -2. So n, we divided both sides by a negative, flip. So +5. N is greater than or equal to 5. So 5, 6, 4, 3, 7 over here. All right, open or close circle. Closed. We want the numbers bigger than it, so left or right? Right. Awesome. All right. So, which of the following inequality statements is represented by the graph below? So first, I see that it's a closed circle. Well, they're all are equal to, so that doesn't eliminate anything. I'm gonna go ahead and solve these. So plus 2 to get rid of, plus 2. So x is less than or equal to 6. Minus 2, minus 2. It's all process of elimination with these. So we're just gonna go ahead and solve it. So x divided by 2 is greater than or equal to negative 8. We get rid of division with multiplication. X is greater than or equal to negative 8 times 2, negative 16. All right. We get rid of division with multiplication, so we're going to go ahead and multiply both sides by 2. So x is greater than or equal to negative 4. So right off the bat, 4 is highlighted, negative 4. So it's not this one with x being less than or equal to 6. It's not this one with 16. It's one of these two with 4. And it's already trying to throw us off because they're in opposite orders. This one has 4 first, and this one has x first. So I'm going to go ahead and turn this around because this says x is less than or equal to negative 4. And this one says it's greater than. So right there, my last thing is to decide, did they shade to the bigger numbers or the smaller numbers? We shaded to the right, which means that they shaded all the numbers bigger than it, which would be x is all the numbers greater than or equal to negative 4. So then in your last thing, I want you to make sure in your notes you include a summary of today's lesson. What did we talk about? We practiced translating inequalities. How do you translate an inequality? Well, you practice those phrases. To use that chart, or remember that in order to translate it. And once you've translated it, use the same process of solving them. So in order to translate an inequality, what do? That's part of your summary. Once you've translated the inequality, how do you solve it? All right. Once you solve it, how do you graph it? Nope, that's it. All right, so make sure you get all of that because that's all part of our objective, which is a good summary for that last part. If you didn't get those ones I had you do on your own, definitely come to small group. If you did, but you still feel like you need some practice, come to small group. If you feel comfortable with it, do your Schoology assignment. Otherwise, guys, have a great day. I will see you. Bye.